Yes, ma'am, you can start.
Okay. Good evening, everyone. Once again, I welcome you all to the third and final session of this international webinar on sensors and applications. I feel privileged and extremely happy to welcome and introduce our speaker for this session, Dr.S.A.Martin Britto. Now he is going to deliver his talk on shock waves, a new tool for sensor applications. He is currently working as an assistant professor in the Department of Physics, Sacred College, Tirupathur. His area of research are spectroscopy, shock waves, and crystal growth. He received his PhD degree in the field of crystal growth from Madurai Kamaraj University, and he did his postdoctoral research in Department of Inorganic and Physical Chemistry, Indian Institute of Science, Bangalore. He has received many awards and fellowships from the prestigious institutes in his research career. And here I am mentioning few. He has received University Stipend Research Fellowship from Madurai Kamaraj University in the year 2005 to 2008. He received a centenary postdoctoral fellowship from Indian Institute of Science, Bangalore during 2009 to 2011. And Dr. Kothari postdoctoral fellowship from DST New Delhi from 2011 to 2012. And he received Best Innovation Award from Society for Shockwave Research, India in 2016 for the development of bicycle assisted shock tube. He was selected for Young Scientist Fellowship Program by Tamilnadu State Council for Science and Technology in 2017. So far, he got 3 research projects, including one major project worth of 22 lakhs from BRNS, Mumbai. Dr. Martin Britto has published 110 international journals and 4 national journals, and has organized 5 conferences and presented his work in more than 20 invited talks. He has filed 5 patents so far and many more to come. So we have such an eminent and renowned personality as a speaker today, who is always inspiring young minds towards physics and research. On behalf of the Auxilium management, faculty members, and students, I extend my warm welcome to our speaker, Dr. S.A.Martin Britto. I ask the audience to give your full attention to Dr. Britto. If you have any questions, please write them in the chat section. Those who are not in Zoom can unmute and also ask your queries. Now, without further ado, we will turn the time over to Dr. Britto. Over to you, sir.
Thank you, ma'am, for your kind words about me. And very good evening to all, especially the Secretary of the College, Principal and Vice Principal of Auxilium College, and the convener of this program, Dr. Nisha, Head of the Department of Physics, and organizing committee members, and my dear participants. Good evening to all. The topic of today's seminar is shock waves, a new tool for sensor applications. I hope you people are for the past 2 days you are enriched with the basics of sensors and applications of sensor, and those things already you got, I hope. I have selected this particular topic for 2 reasons. One first primary reason is actually to give an exposure about shock waves to the young researcher like you people. The second aim is actually, in general, if you ask to the researchers, they will tell, I am not able to do much because I don't have much facility in our college or in our university. They have no such big facility, so I am not able to do much like that. Just to answer for this, respond to this particular questions, I will introduce a few the concept about this shock wave and how we can use this shock wave for research purpose with very low cost, without any much investment, without much knowledge on engineering. you can do very good research and you can come out with a very good publication. That's what I wanted to insist to you, impart to you. That's what I chose this particular topic for this international webinar. My content of this talk will be, I have divided into two, part 1 and part 2. In the part 1, I will give a small introduction about this sensor, very simple introduction, and then I will tell what is shock wave and what is shock tube, how you can make create shock waves, and how you can play with the shock waves. That's what I will give some glimpse of research what I have done so far, like that. Second part, actually, how this shock wave can be used in research and sensors, and especially nanomaterials like that. Then I will conclude my talk. I hope I will take 45 to 50 minutes. As we know, everybody is actually now we are living in a world of smart sensors. Without sensor, there is no new technology and new achievement like that. I hope the past two resource persons gave the basic about the basic, and from basic to advanced parameters of a sensor they have given. So I don't want to go inside. So just I presumed that you understood everything and you know all basic about sensor. So I will simply for the continuation of this talk with the sensor, I want to give only 2 points I want to insist. As the previous resource person, Dr. Dayalraj, very nicely he told about the characteristics of a sensor, reliability, accuracy, repeatability, all these things. Apart from these all things, a sensor should give some measurable change in the output for a known input stimulus. I start from this word stimulus. Stimulus. Actually, it will induce some changes in a particular material. That is called a sensor. The stimulus can be a pressure, temperature, light, stress, vibration, or etc. These are all the actual stimulus. The main point of my talk is actually, if the stimulus is very sudden change, or suppose I am using a sensor in a harsh environment. For example, I am sending a rocket to the space. Rocket will go very fast, very high speed. When very high speed things are happening, whether this sensor material will withstand for the particular application or not, that we have to check. And whether a sensor can come to its original position after reading the actual measurement, physical quantity. These are all another additional point for a sensor, which can be used for all other high advanced technologies. This is we are. I have a sensor. It is a very good only, but suppose if I want to improve some parameter of a sensor, for example, the sensitivity of a sensor. Suppose if I want to increase or enhance or improve, what I can do, I can go for 3 methods. One is doping, or if it is a nanomaterial, by changing the surface morphology, you can enhance or improve the sensing property of a sensor. Or this is very little new now, actually. Designing the disorder in the crystalline materials. As you know, the sensitivity of a sensor depends on the atomic arrangement, the degree of crystallinity of a material. In some cases, if you can make some disorder from outside in the sensor material, then the sensing capability may increase. It may or may not. In some cases, specifically, if you can make some disorder in the atomic arrangements, you can enhance the this sensing property. That's what we are going to see today. Now, as I told you in the previous slide, there are n number of stimuli are there, external stimuli like light, gamma radiation, or pressure, temperature. Similarly, one more tool is actually called shock waves. Now I will spend another 10 minutes just to introduce shock wave. Some of you may be aware of this term shock waves, and some of you may not. Just I will give some glimpse on those things. Right. What is shock wave? What do you mean by shock wave? Shock wave is nothing but any sudden release of energy within microsecond will result in the formation of shock waves. Shock waves can be generated mainly by two ways. One is natural, another one is artificial. Natural, how it can come up? Naturally, in general, shock waves will be generated during the earthquake, tsunami, lightning and thunder, and etc. Even volcanic eruption also shock waves will generate. Artificially, also you can generate shock waves. That is by two ways. One, you can generate shock waves by bomb blast or supersonic flights. When the supersonic flights are moving very fast, they will generate shock waves. And rockets. Rockets also can generate shock waves when they are going very high velocity. Whenever an object is moving with the velocity more than the velocity of sound wave, then such objects can generate shock waves. These shock waves can also be generated by shock tubes. We will discuss later those things. Why we need to study about shock waves? The materials which are used in supersonic velocity by vehicles and pulse laser devices have the probability of exposure of shock waves. As I told you earlier, when a rocket moves with a very high velocity, they will generate shock waves. That shock wave can be hit on the can hit the rocket or satellite. If that such type of heavy power shock waves hit the surface of the satellite or rocket, those rocket or satellite will be collapsed. Hence, so we should know the effect of shock waves on materials, especially such a type of high-fi technological satellite or rocket or some defense things, as well as whenever the nuclear power plant is running, inside the shock waves will generate. So the materials which are used in this such type of active what you can say reactors, the material should withstand the shock waves. When shock wave passes through a material, that shock wave can interact with the atoms, molecules, and atomic bonds. They can alter the bonding, atomic bondings of a molecule. So this is just I am showing you two photographs. You can see this is actually the rover which was sent by NASA. It is actually entering into the Mars atmosphere. You can see this is a plasma embedded with shock waves. Since this satellite is actually suddenly hitting with this atmosphere of Mars, the shock waves are generated. If the material made up of this satellite is actually if it cannot withstand the shock wave, then it will be damaged. And this is actually the China's spaceship entering into the atmosphere. So actually this is a shock wave. Right? Not only the shock waves can be generated by this type of spaceships. Even if you drop a stone from your hand, when it can hit the surface of the earth, it will generate a small amount of shock, very mild shock. I could say this small shock is good enough to interact with the atomic scale of that particular stone. Suppose that atomic bonds and the electronic structure of the atom is susceptible to this particular shock wave, it can change its property of things. In general, these shock waves are in general destructive in nature, as earthquake, tsunami, volcanic eruption, thunder and lightning. During those events, the generated shock waves will always destructive. But if you can control it and channelize it, you can use these shock waves for constructive purposes. Shock tubes. Suppose if you want to generate shock waves in the laboratory, there are some instrument that's called shock tubes. Shock tube is a device which can produce shock waves. In general, shock tubes got 3 sections. One driver section, one driven section, and diaphragm section. In general, the conventional shock tubes are huge actually. Even in India, we have shock tubes in 4 or 5 places, especially in IISc Bangalore and IIT Mumbai, IIT Delhi, and IIT Madras. All these 4 places got a huge conventional shock tubes. The size of a shock, you can see the picture itself, you can see the length of the shock tube is more than 100 feet. That much huge. Type of shock tubes are used for aerospace dynamics and aerospace departments. Before launching a satellite, the scientists used to generate shock waves by using such type of shock tubes and expose that shock wave on the satellite material. If the material could withstand this amount of shock wave, then that is allowed for flying or launching to the actual space. But generally, this type of shock tubes and shock waves are used by aerodynamics department only, aerospace and aerodynamics departments, till 2010. Around 2010, one person, Dr. KPJ Reddy from IISc Bangalore, came up with a very good idea. Till then, there was a myth such a way that a shock wave cannot be generated by a human. But Professor Reddy told that no, even human hands can generate shock waves, and that such shock waves can be used for very good applications, from medicinal to industry like that. What was his achievement? No, he actually generated a shock wave by using ordinary syringe, medical syringe, what we are using for injection. You could see the photo here. See, it's ordinary syringe. As I told you earlier, a shock tube got 3 sections: one driver section, one driven section, one diaphragm section. Here, this is he took it as this is the driver section, and this is driven section, and this is diaphragm section. Okay. What he has done in the piston, in between the piston and this needle, he put a plastic paper, ordinary plastic sheet, and fixed that needle. Then what he has done is pushed this one. So it is blocked. The pressure developed here, and he pushed it and again pushed. At a particular pressure, what happened? This plastic sheet ruptured. As per the definition, if there is any sudden release of energy, shock waves will generate. The same thing happened here also. He told the energy is suddenly released, so the shock wave is coming out. But people didn't believe it, because scientists will not believe simply without any scientific evidence. So what he has done, he fixed a very sensitive and high-speed camera towards the tip of this sharp tube, this tube. Then he pressed this, and at a particular pressure, this diaphragm ruptured, and these waves came out. He measured the temperature and the pressure of this wave. It was actually 900 Kelvin and 3.5 megapascal, and the velocity is more than 500 meter per second this wave. So it is he defined it is sharp. People believed it. So it was called by his name, called Reddy tube. So now now such a type of many sharp tubes are called as Reddy tube. Then what he has done, just think about it. So imagine just this ordinary syringe, 5 ml syringe, by pressing and rupturing this diaphragm, a shock wave is generated. That shock wave consists of the temperature of the wave is 900 Kelvin. You just imagine about it. And pressure is also 3.5 megapascal. It's a huge pascal. But he proved it. That's what the scientific community accepted this one. And he has done enormous amount of work on this part. He actually, I listed a few, many. I will tell only few things. That's kidney stone treatment. What he has done, he generated the shock wave. Before that, I want to show you one thing. Then what he has done, he made the same syringe in metal piece by using a metal piece. There is a flange, it is lying down. You just put it and you can press it. You can keep the diaphragm here and shock wave will come out this side. Right. So by using this metal shock tube, he has done many things. That's what I am going to tell. Suppose if you got a kidney stone, what you have to go for medicine or you have to go for surgery. What he has done, just this, he focused that shock wave on the place where the shock wave is, where the stone is. By using that shock wave, when you expose the shock waves, it will penetrate through your body and reach the kidney and break the stones. Then the broken piece of stones can come out through the urine. So now this type of treatment is coming up popular because no pain, no blood, very fast treatment. Even within half an hour, 1 hour, your kidney stone will be removed by using this shock tube. Then what he has done, shock wave assisted needleless drug delivery. Suppose if you want to inject some medicine in your body, you have to use the injection. By some needle, you have to pick it and send the medicine to your body. What he has done, you can see the picture. You can put the medicine here and just send it on shock wave. It automatically will go inside. The medicine will go inside. That's what he named needleless drug delivery. And so many applications he has done. Right. What actually once I saw the instrument, I wanted to do something on this shock waves. But the cost of this Reddy tube is actually commercially available nowadays, but the cost is still huge, 3 lakhs rupees he is selling. But it's very difficult to buy an ordinary small research laboratory to buy that shock tube. So what we wanted to do is we wanted to make a shock tube in our laboratory. Very simply, we have done a long history, but I want to show the results of it. We have just replicated the shock tube of Professor Reddy. Just you can see this. See, this is an ordinary tube. 2 tubes are there. This is driver section. This is driven section. In between, a diaphragm is there. What Reddy used, he also used the same thing, but he used a piston inside. Technologically, engineering part of view, pushing a metal piston inside without air leak is tedious job. So that will make the big cost. So what we have done, just we have replaced that what is called that piston and attached a cycle pump here. And I have put a paper diaphragm here. Now, if you increase by using this pump, if you can increase the pressure here, at a particular pressure, this diaphragm will rupture. So shock wave will come out. Just I will show you the shock tube to you. Could you please I request the participants to just pin my video. See, this is actually two cycle pumps. That's two tubes. You can see. You can see see this is one tube. This is one tube. You can see this part. It's just one metal plate, and this is another tube. You can see this one. It's another tube. This is the part you can fix the cycle pump, right. In between, you can keep an ordinary paper. You can put like this. You can like this. I can put like this and make it and put this clamp. There's a clamp here. Just I will show you. Right, like this. Similarly, you can put 3 G. These are called as G clamps. G clamps. You can see, get it in the market itself. You can see the G clamps. So now what you can see is that you can just fixing these things. You can put the cycle pump this side and operate it. When you are operating the cycle pump, this area, this is called driver section. This area, the pressure will develop. At a particular pressure, this diaphragm, it's ordinary air-4 state, carbonless air-4 state, that it will rupture, right now. So when it is a rupture, energy is suddenly released. So as per the definition, shock wave will generate. So shock wave will come through this end. This part is called driven section. This is the shock tube. Anybody can make it in the laboratory. It will make around maybe 500 rupees. It will cost, right? So by using this shock tube, we have done some research on this. As the strength of a shock wave can be measured by a term that is called Mach number. The Mach number of this shock tube is actually 2.2. The actual ready tube can generate shock waves up to 1.5 Mach number. So this shock tube, low cost shock tube, is much stronger than that actual original ready tube. So Reddy actually put a name for this particular shock tube as bicycle assisted ready tube. Now we will see what I can do. We can do by using this small gadget. That's the thing we are going to do it. This is the actual setup. You can see I have put it as professional. I have put it as stand and put it this. You can just do upstroke. You can get a shock. You can do many things. This is we have made another automatic shock tube. By instead of this pump, we have fixed some automatic things. Then automatically n number of shocks can come out. Okay, right. What we have done with this one? What is the features of this novelty of this ready tube? It is very small size than conventional one. Conventional shock tubes occupies a huge place. You need at least 200 feet long laboratory to keep a shock tube. But this you can keep it in a table itself. That is small in size. And this type of shock tubes can generate shock waves with the Mach number 1 to 5. 5. So 5 means a huge strength, very deep, it's huge actually. And this automatic shock tube can generate more than 25 shock pulses per minute. Here, I want to mention one thing. In this case, how shock waves generated. So, actually, you are increasing the pressure here. Na? In this place, you are increasing the pressure. This pressure, at a particular pressure, it will rupture and it will come out. What will happen? The whole air will compress here when it's coming out due to the terminal velocity. they will form a small thin layer of air. The whole air compressed, and particularly becomes a thin layer of air. And this thin layer passes through like this. That's what. So this air layer is actually called as shock wave. This air layer will move with the velocity more than the velocity of sound wave. This air layer is actually called as shock waves. This is, anybody can operate it. There is no need of a professional operator for operating this type of shock tube, and cost is very less. Even within 1,000 rupees, you can generate, you can make a fabricate a shock tube. Now, whether this shock tube, what we can do with this shock tube, with sensor application. The title of the talk is actually sensor applications. What we can do with these shock tubes and shock waves. As I told, these shock tubes or shock waves can be used to check the stability of a sensor material. As I told you earlier, if you want to use a sensor in the satellite or in a rocket or in a military tank or in a nuclear power station, there are huge amount of shock will generate there. You can, but you should know whether the material can withstand the shock wave or not. To check, you can use the simple gadget for these things. First point. Second point, a material can act as a sensor or not. That you can check. I will tell you. Later I will tell you how you can do it like that. And third point, you can improve the sensing properties by using the shock tubes or shock waves. Right? Why the shock waves is special? As I told in the beginning, I told there are few stimuli you need for sensing: pressure, temperature, vibration, light, gamma radiation, like that. In all the senses are working with but one input. But this shock wave consists of pressure, temperature, stress simultaneously. Therefore, you can check a material or sensor with 3 parameters simultaneously: pressure, temperature, stress. So, ordinary, as I told, ordinary sensor can respond to one single pulse or single parameter. But this shock wave consists of 3 parameters. So you can check a sensor whether it can withstand the shock wave or whether it can accept 3 parameters simultaneously or not. For real-time applications, for actual field of the technology, you have to check all these parameters simultaneously. Then only such sensors can withstand in the harsh environments. Right. Just for an example, I am showing these things. This Lavanya et al. They have prepared tin oxide nanomaterials, and they exposed that material on gamma rays, and they have found the sensitivity of that SNO2 improved a lot. What they have done, they have made this SNO2 nanoparticles. That's a sensor, actually very good. It's a gas sensor. Then they have exposed gamma rays on that one, and they found the sensitivity of that sensor improved. And Dr. C. Shekhar from Lahapa University tried in the same way. He made tungsten trioxide nanoparticles, and he was trying to sense some serotonin sense. I mean some gas sensor he has made, and he tried what is the impact of gamma rays on that tungsten trioxide sensors. Then he did it. He exposed 100 kg of gamma radiation on that tungsten trioxide, and he used that sensor for sensing purpose. Surprisingly, the sensitivity of that sensor was enhanced in a very good manner. He got a paper also here. sensors and applications. And the same Lavanya, again she has, that group has done another one material, tungsten dioxide, that is tungsten oxide. That's also another very good potential sensing material. And he exposed this gamma rays on that particular material. But they have not identified any enhancement of this sensitivity, sensing efficiency, but it was working. So from these three work, we can understand that if something, some radiation or waves hit the sensor materials, that will be affected. That will be something will happen like that. It may enhance, or it can decrease, or it can withstand as it is like that. In that way, we also tried the same way. Instead of this gamma radiation, whether the shock wave works or not, that we wanted to check it by this shock tube, right? This is one paper, recent paper from our group with collaboration with Dr. Shekhar from Alhappa University. What we have done, actually, Dr. Shekhar, what he has done, he prepared some ferrous oxide nanomaterials. This is the XRD. You can see the XRD of the ferrous oxide nanomaterials. Then he gave around 100 pulse of shock waves on that material. Then he took again recorded the XRD. You can see there are some changes. This peak, particularly this peak, is absent in the case of shock exposed material, and few peaks are disappeared. But all other peaks are as it is. So there is no change in the molecular part or crystalline part, but there are something happened inside. So what he has done, he has made the Raman studies. There also he could see some differences. See, this is the control, and this is a shock exposed. This is a lot of differences he could. Then what he has done, he wanted to check the property of sensitivity. Sensing property of that particular things against to find actually just a minute, uric acid, folic acid, and riboflavin. Right. He surprisingly, you can see what he has done. He took the material and gave 50 shock, 100 shock, 150 shock, and 200 shock like that he gave. Surprisingly, the 150 given shock given material shows very good efficiency on all others. You can see in the next plot. You can see he has identified those things by cyclivoltometry. See, this is 150 shock exposed sample, gives the uric acid sensitivity enhanced, folic acid enhanced, riboflavin has enhanced a lot. So shock wave exposed materials, they have enhanced the sensing property of the particular sensor. So he concluded such a way that shock wave is a very good tool to enhance the simultaneous sensing of uric acid, folic acid, and riboflavin in a very good manner by using the shock waves. So the shock wave is one of the very good tools he identified. Then we have done another one, a very interesting experiment. We have grown some crystal, one crystal, potassium sulfate crystal, which is shown here. And we have given only one shock, and this is the XRD of that one. You can see it's a single crystal, and we have taken a XRD. It shows the very good crystalline nature, and we gave only one shock. After we recorded that XRD here, XRD. You can see this is only one peak XRD. Then it is become something else. You can see this peak completely vanished and two new peaks have come. Actually, this is actually hexagonal system. After giving the shock, it became orthorhombic. I think somebody is talking in between. The organizers, can you mute the mic? Okay, thank you. Then what we have done, we have given another shock on the same crystal. Surprisingly, interestingly,
it's 4 o'clock. We were 4:10, 4:05. We have to conclude. So with the vote of thanks, everything. So you can take 5 more minutes, 10 more minutes. The questioning session also will be there.
Okay. I will take another 10 minutes then. 5 to 10 minutes. Okay. Thank you, ma'am. So this it is completely reappeared. The shock exposed is actually become as another space group, and again we gave the shock, so it came back to the original position. So switching of molecule. The solid crystal changes its actually crystallinity in different space group by a single shock. This type of switching molecules can be very well used in the sensors. That's what the thing is. So you can see if you give this a control, if you give shock, the resistance is actually increased. So the second shock, it came back down. This set, reset, set again. So this is a control. This is actually increased and this come down. You can see this very well. So see the tau modulus. See 5, 2.8, 8.4. So it is initially this one going down and going up. So it is actually flipping, actually switching. This is one of the very good property of a sensor. It is recently published in Govt and Design. Another one material actually cobalt oxide. So this also we have done. So you can see it's another interesting material. We have prepared cobalt oxide and measured the magnetic properties. You can see it is a very well super paramagnetic. We have given 50 shocks. It is become as paramagnetic. Again we have given 50 shocks. It is become again it becomes a super paramagnetic. So again switching. This type of magnetic switching can be very well used in the magnetic sensors, and it's recently published in physical chemistry. The physical chemistry. This is also another one material. Just I will skip it since because of the time. This one, right? This is another ordinary calcium carbonate. We have grown calcite crystal, and this is exactly, and we have given actually 150 shock. It becomes calcite 2. Again, if you give shock, it becomes calcite 3. Again, if you give 50 shocks, it becomes again calcite 2. Again, it becomes so. If for each and every shock pulse, it is changing its crystalline nature or space group or another. It is forming as another calcite, another polymorphic nature of the calcite. Calcite 1, calcite 2, again calcite 3, again calcite 2, calcite 2. So it is a switching array of switching. This is called a ternary switching. These type of results we got only from this ready tube bicycle assisted ready tube. I will skip all these things and I will come to the summaries because of the time. So we have discussed the origin of shock waves and the impact of shock waves in nature, ready tube and its applications, and impact of shock waves on this sensor materials. These are our group. This is a person who actually, Sivakumar, he actually fabricated the shock tube. This is Rita, she worked in this type of magnetic material and he found so beautiful result. He's also Dr. Madhavan, he's actually working in shock. This is our research group. For the contact, this is the things you can see it. Thank you. Over to the organizers.
Thank you, sir. The participants can unmute and you can ask your questions. Sir, we were talking about the switching property of the sensor.
Yes.
Will it not the shockwave damage the sensor material over the time? What about the lifetime of the sensor?
Pardon?
Lifetime. Because the
Lifetime.
shockwave will damage the sensor material properties.
Yeah,
The time.
yes, it's a very good question. Whether this shock wave will damage the sensor or not, you are asking like that, na?
Yes,
That's
sir.
that's a one part of the work actually. Uh, all the materials will not be affected by shock waves, damaged by the shock waves. Some materials can withstand. Such materials only can be used in the space vehicles and nuclear power plant and military applications. That's what we can use this shock tube, ready tube, to check whether this type of material can be used in space or not. That is the idea. In some cases, the materials will be completely damaged.
So the space vehicles, we can use this kind of material.
Yes.
Okay. So there is one question in the chat box. What is meant by Mach number in shock waves?
Mach number means actually, as I told you earlier, if a wave is the velocity of a wave is more than the velocity of sound wave, then it is called a shock waves. Mach number is equal to the velocity of this wave, shock wave, divided by the velocity of sound wave. If it is more than 1, then that wave can be called as shock waves. That's what the shock wave which is coming from this ready tube is actually more than 2, 3, 4, 5. So the Mach number is 4, 5. 3 means 3 times higher than the velocity of the sound wave. That is called Mach number.
Okay, so there is one more question. Shock wave is a direct sensor or not?
Shock wave is not a sensor. It's a tool to identify a sensor and a tool to enhance the sensing property of a sensor. It's a tool. That's what I put it in the slide. Shock wave is a new tool. It's not a sensor. Actually.
There is one more question. Can we produce shock waves by using hard metals?
That is, you can also use shock waves by using hard metals. That is called plate impact method. Some heavy metals plates will be projected in very high velocity. They will hit the sample and they will generate shock waves inside the sample. That's another type of shock. That's called actually. That's another type of shock wave that is called. This is called dynamic shock waves. What we are doing.
Okay, sir, is there any range of Mach number that we can use in sensor type materials?
In general, the Mach number between 1 and 3 can be used for ordinary sensor materials. But that is okay, perfectly okay. Up to 3 is perfectly okay. Even if you are using that sensor in the space vehicles, especially outer body of a rocket or satellite, the Mach number should be more than 5. You have to check by using that. You have to check that such type of sensor with the Mach number more than 5.
So what are those materials that can withstand up to Mach number of 5?
It's a very good question. In general, the people have identified copper oxide and tin oxide also. I remember like that. Copper oxide is a very good material for shock withstanding, resisting materials. Copper oxide, zinc oxide, yes, also.
Okay, thank you so much, sir, for enlightening us about the sensors and the interesting role of shock waves in the field of sensor. That is a very new idea for us. It gave a very deep insight into the topic and also revealed some interesting facts about the shock waves and its applications related to sensors. I'm sure the participants will be benefited with the information shared by you, sir. Thank you so much, sir. Here we come to an end of the beautiful day and end of this wonderful event, the international webinar on sensor and its application. The roots of all goodness lie in the soil of appreciation, said Dalai Lama. On behalf of organizing team, I deem it a great honor and privilege to propose the vote of thanks on this occasion. First and foremost, I express my sincere gratitude to all the distinguished invitees presented here for enlightening us with their commendable talk on the subject and enhancing our understanding pertaining to sensor and applications. Conducting this international webinar would have been impossible without the zealous efforts of Dr. Nisha Shantakumari, the coordinator of this webinar, head the Department of Physics at Auxilium College, who has devoted lots of time and energy for this program. I express my heartfelt gratitude for Dr. Nisha Shantakumari and the organizing team for their dedication and enthusiasm. I extend my special thanks to Mr. Dinesh Gajendran and his team for the assistance to carry out this event successfully. We are grateful to the management of Auxilium College for its support and encouragement. Furthermore, I thank the student volunteers for their helping hand behind the screen. I express a deep sense of gratitude to all the participants for your patience in listening and active participation in all the sessions. Above and beyond, I give glory to the Almighty God for making this international webinar a resounding success. Once again, I thank each and everyone. Now participants can switch on your camera for their photo. Ma'am, is it done now?
Yes, sir. Yes, sir. Thank you, sir. Thank you. And thank you, participants.
Thank you, ma'am.
Now you can wait and fill up the forms, feedback forms. Don't leave, please.
Shall I leave, ma'am?
Yes. Sir, yes. Thank you very much, sir. Dr. Martin, Britto.
Thank you.
Thank you very much, sir.
Thank you.
I request the participants to fill up the feedback form.
I have received the certificate, ma'am. Thank you, ma'am.
Roshini, no voice.
Ma'am? Excuse me, ma'am.
We could not hear the song. Roshini?
Yes, yes.
I have received the certificate, ma'am. Shall I exit, ma'am?
I have finished filling the form.
Ah,
Yes.
yes, ma'am. I have got
Automatically
certificate, ma'am.
generated, and it will
Thank
receive
you,
it.
ma'am.
When you finish, you can leave. As you finish the feedback form, thank you very much. Thank you. We'll meet in the next webinar.
With a grateful heart, with a song of praise, with an outstretched arm, I will bless your name. Thank you, Lord. I just want to thank you, Lord. Thank you, Lord. I just want to thank
ஜான்சி கிச்சல தண்ணி ஊத்தாத எதுவும் பண்ணாத கிச்சல தண்ணி ஊத்தாத
Ma'am, I didn't receive my certificate, ma'am.
Ma'am, I received my certificate, ma'am.